Dimethylamine has a Kb of 5.9 times 10 to the negative fourth. What's the H3O concentration in a solution that initially contains just 0.1 molar dimethylamine? Alright, that is just the initial concentration of a weak base in water. That's going to make some Hb plus conjugate acid of that and some OH. So I am expecting this to be basic. I have initial concentration of 0.1. I never worry about that. I'm assuming this is 0 because it didn't say anything. And I'm assuming this is 1 times 10 to the negative 7th because it doesn't say it's not neutral. So my base is going to drop. The conjugate acid's going up. And at equilibrium, I'm expecting this to be 0.1 minus x. This is x, and this is 1 times 10 to the negative 7th plus x. All right. Standard base equation. I have my Hb plus. I have the OH minus. And I have base. All right. If I want to solve this and get the OH, or I'll end up getting the OH concentration, so solving for the x, I can do that with the graphing calculator. So I'm going to plug in the Hb as it is, and the OH is 1 times 10 to the negative 7th plus x, and then I'll divide all that by 0.1 minus x, put the invert there to put it in the bottom, and that would be everything on that side of the fraction. So now I need to subtract the Kb. When I graph that, I get something reasonable. So I'm going to calculate the x, and I want to find out where it's 0. So I know it's going to be larger than 0, because that means it still goes forward some, but it can't be larger than 0.1. And then back up and have my guess at 0, and I get an x that way of 0.00739. Now I want the OH concentration, so I'm going to take that x, 0.00739. Technically I'd be adding the 1 times 10 to the negative 7th to get the actual OH concentration, which I'll take the negative log of. No, I don't want to do that. That'd give me a pH. I'm looking for the H3O concentration, so rather than that, I'm doing 1 times 10 to the negative 14th, the Kw, divided by the OH, and I get an H3O concentration of 1.3, well, 1.4 times 10 to the negative 12th. Now, in class, we showed how we could do this as an approximation, and when we approximated it, we basically left this at 0.1 instead, and this x and this x. So instead of having to do the graphing calculator, I just ended up taking the Kb, 5.9 times 10 to the negative fourth. That's going to be equal to x times x over just 0.1. So I'll multiply this by 0.1 and then do the square root of that. And I get an x of 0.00768. So the x is slightly different. But when I get the difference between that and find the H3O concentration, I'm going to have almost the exact same value. 1.3 times 10 to the negative 12th. So within a very reasonable amount of error, same number essentially.